but I want to remember the time that I sounded like this. All right. That's fine. Okay, cool. What's that? All right. Then we've got this kind of stuff here. Now, to me, Math 90 and 110, one of the main things you have to learn is solving equations, right? And as you go throughout your math career, however far that takes you, you're going to learn more and more functions, and they're going to start showing up in equations. So that happened to us already this semester. We learned exponentials and logarithms, and then we did equations that had those in them and how to solve them. Then we did trig functions and equations that had those in them and how to solve them. That's what you keep doing. You keep learning more and more functions that can model something in the real world, and then how to solve equations that have those functions in it. Because in the real world, you never know what function is going to be somewhere that you need to get rid of it, right? Because the whole idea is undoing it. So I give it several of these kind of problems, some radicals, some exponentials. How would you solve that 3C? Okay, sort of, maybe.
Bring the logarithm down.
But bring the what down?
Oh, log.
Use a log to bring the exponent down. Right? So the whole idea there is the only function that's like the opposite of a variable in the power is a logarithm. So that's the only one that can undo that power for me and get that variable free. Do it.
Will you show us briefly on what you
Sure.
Yes, nicely. So you have to argue about it. Okay. Can you please do 3C on the floor, Mr. Waller?
Sure. Then you take. Oh, sorry. So what was it?
Mr. Waller is
The little old man. Was it at 29.6? So Lydia, the way that you said it is right. You don't have to do it that way. You could rewrite this as a logarithm and then use change of base, right? But the more direct way is just to take a log of both sides. And which log do we normally use?
Log 10 or log 10.
You can either use log 10 or natural log. Natural log is used more often because it has one less letter. Now, this is a point I try to make with trig. I am not multiplying both sides by ln. That makes no sense. ln by itself makes no sense. It's like saying that this is somehow square root times 4. No, it's square root of 4. So I'm taking the log of both sides, not multiplying both sides by ln. You understand? So be real careful. If you say anything like that in your next class, your calc teacher has every right to, it's because I smacked you across the face, but probably not. But at least think about it. So what happens? Why do we do that log? What happens now?
This one that comes down.
Yeah, this power comes down.
Divide by the log.
Not yet. I would not do that yet. I don't want to carry decimals around forever. Screw that. Let me do the calculator last.
Divide by
Next
log.
thing I would do is divide by ln 5. Get that the hell out of the way. Right?
So that becomes ln 29.6 minus ln 5, right?
No. You cannot make division become subtraction. The rule is, if I have a log of a quotient, that's the difference of the two logs. This is not a log of a quotient. This is a quotient of two logs. I can't do anything with it. And that would be what it would look like if you did the change of base.
I don't remember.
Now you just got to get x by itself. Right, so you subtract 2 divided by negative 5, not a big deal here, right? And just plug that whole thing in your calculator, see what it does. So subtract 2, divide by negative 5. So you get x equals this business here. So that's the exact answer. And if you plug in the calculator, you get a decimal approximation. So let me show you something. How do you do that in the calculator? So if you want to do that in calculator, let's see if I remember what it was. So it's the natural log of 29.6 divided by natural log of 5, right? Minus 2. So see how I put all that in parentheses. So that's the top divided by the bottom, which was negative 2, right? Negative 5, thank you. So you get that mess there. Is that cool? Be real careful about parentheses. You don't want to close parentheses until you're done, but don't forget to close them. If you forgot to close, then like after the 29.6, then the entire thing is going to be inside that first natural log. That is very different from what you want. Okay. Good, that's about what I got on the answer key, yay. Now here's a really cool way to check yourself. Check yourself. Well, if you take this and raise 5 to 5 to the 2 minus 5 times that, what should my answer be? 29.6. And if it is, that's true. So I would take 5 to the, I just forgot what I just said. 5 minus 2x. 2 minus 5. 2 minus 5 times answer.
Crazy, doesn't it?
Cool. Remember that answer key? That's temporary memory. It holds the last number that came up on the screen. And you get 29.6 kick ass. So then you know you're right. So the thing you learned in Math 88, or its equivalent, when you first learn how to solve equations, how do you check your answer? You plug it back in. Same thing here. How do you check your answer? You plug it back in. Yep.
You know how you subtract the 2?
See?
You know how you subtract the 2?
Yes.
You divide the log, the natural logs, and then subtract 2?
I have to. I'm not sure what the question. I have to divide these and then subtract 2. Understand?
All I know is we didn't divide them. Like, we didn't subtract them.
It means like you can divide the logs.
I can't divide this by this, right?
Yeah,
Not the 29.6 divided by 5. I could take this divided by this, and then it's going to be this long decimal. I don't want to do that. I'd rather get the whole thing, like the whole thing in the calculator out once, and then round that answer. Cool. Okay.
I just carried it over.
What's up?
I carried it over because I don't have my calculator.
Carry.
I did the division, equals, and minus, equal, and then divided by 5 equal.
Oh, sure, of course. Okay.
Whatever.
As long as you don't round in the middle, you're fine.
Yeah.
Okay. Now here's something a little more recent here, like 3E. Yeah.
You get rid of absolute that absolute.
Oh, here for D. All right. Maybe turn on one set of lights for me. I don't know if everybody can see the board.
Okay.
Okay. So everybody got my office hours here written down? All right.
I'm sorry.
So let's see.
And then I'll be emailing.
All right. So how would you solve if it was this problem instead? How would you solve that problem?
Radical right out.
Yeah, isolate the radical, right? So that idea carries through a lot of equations in mathematics. You isolate where your x is stuck first, and then you somehow undo that thing. Now the absolute value is one of the ones that you can't apply a mathematical operation on it. You have to apply the idea of absolute value to do it. But you still, the first step is the same. Isolate where my x is. So subtract 2. Now, if the absolute value of some number is 6, what must be true about that number? It's got to be 6, or it's got to be negative 6. So 3 minus x is 6, or 3 minus x is negative 6. So whenever you have absolute value, you're always going to have two cases. In the more extreme problems, one of those cases, or both of them, might be false. But you've got to start with the two cases and do the math and see where it goes. In this case, I'm going to get two answers here.
Plus or minus 3.
No.
-3.
Yeah, so if you subtract 3, divide by negative, you get x equals -3.
Oh, yeah.
Or subtract 3, divide by negative, x equals 9. If you think about it, what does this really say? What number is 6 away from 3? Well, if you go up 6 from 3, where do you end up? 9. If you go down 6 from 3, where do you end up? All right. His absolute value is distance. So it says the answer will be all the numbers that is 6 away from 3. Bam. That's another way to do that problem. You can actually do this problem visually then on a number line. Okay, cool. Because it's relatively simple. I don't have very much stuff inside. All right. What about part E? I kind of purposely put that on there.
Is that from chapter 8?
Yes, sort of. It uses, I'll give away a little something about that. It uses an identity. That's the best way to do that problem. What identity jumps out at you possibly? All right, actually, let me start here. What really sucks about that equation besides it's got trig in it?
It's not an addition, it's subtraction.
And what sucks about this is there's no real way to get my x by itself easily. Not directly. I could add this over and take the square root of both sides. But oh my God, that does nothing for me. Then I have the square root of sine squared minus 1/2. Screw that. So this is where identities come in very handy to solve these kind of equations. Who remembers what cosine squared minus sine squared is also known as?
No.
11. So cosine 2x. Right?
What do you do after that?
Say again.
What do you do after that?
Now the cosine of what angle is 1/2? What must this angle be? This angle must be something or something else.
Yeah, 45 degrees.
5, 3.
Oh no, 60 degrees.
My identity is cosine squared minus sine squared is cosine of 2x. That's an identity. Yeah. And it actually uses cosine x plus x. It uses that addition formula.
Oh,
60 or 300? 60?
Yeah. So cosine of 60 would be 1/2 because it's further away from the x-axis. So cosine's going to be small.
300?
So it'll be pi over 3. What goes here? Or where else is cosine positive? Not just the first quadrant.
The 4 pi over 3?
Yeah, the fourth quadrant. So it'd be 5 pi over 3.
Oh, no.
Let me stop right there for a second. We're not quite done yet, but you guys semi with me. So do I care about the 2 at this step? No, I don't give a shit about the 2. I say whatever the hell's in there, whatever this is, it must be this or it must be that. What am I missing here?
2 pi.
Yeah, 2 pi k. And then I say, oh crap, I haven't solved for x yet. Is that how you solve for x?
5 by 3.
Divide by 2, yeah. I like the sympathy base. So x equals, or x equals 5 pi over 6 plus pi k. Shabbat.
I made a cool little simple.
Say again.
That looks so much more complicated.
Then the equation was? Of course.
Yeah. My problem is just converting it to radians. We can't leave it as degrees and have that correct, right?
You can. You could write it like this. If you wanted to write this in degrees. Now my big clue to you was, start getting away from that. Why are radians better than degrees? Besides, I just seem to like them. They're real numbers. Degrees are completely made up. We could have just said, no, I want there to be 1,200 degrees. And everybody went, all right, sounds good to me. 1,200 freaking degrees, yeah. We just totally made them up. So you could say here, what do you guys say here, though?
360.
Yeah. And then divide by 2 and blah, blah, blah. Right? You could do that. But I'm trying to tell you, get away from that. You need to get more used to radians.
As of right now.
Especially if you're going into calculus. But even if you're not, I'd rather see this. I might even say that on the test.
How is
You have. You said it multiple times.
Oh, I
always say
probably
it.
will.
I want to do in degree.
I don't get it. How come pi over 3 divided by
Just because, like, remember in absolute
No, now watch. Listen,
No.
listen. If I cut a pi in thirds and then divide by 2, is that what you're saying?
yeah, it will be 6.
Yeah, of course. I'll get 6 pieces.
I told you I'm not.
Pi over 3 divided by 2 is the same as pi over 3 times 1/2. 3 times 2. Cool.
You took the cosine from the left side to the right side, right?
No. I didn't. No. How do you mean? You can think of it as I sort of took an inverse cosine. Right, sort of. But not really. I just looked at it and knew the angle had to be 60 or down in the fourth quadrant, right, 300.
My question is, like, if it's 2x, would it, because I'm thinking that the x would be 30 because there's 2, is that just not really?
Well, look what it comes out to be. 30. But you don't have to know that ahead of time. You don't have to, the math will do that for you. I could put any number I wanted to there, and this step would have been the same. The next step is divide by whatever that number is. I don't have to have all that in my head at once, thank God. The math will do it for me. Yes.
Are you gonna put any formulas on the test?
I probably will put a few that aren't the ones I told you already you have to know. So if I want you to do some advanced identity stuff that I didn't say I had to memorize, I'm obviously going to put them on there. Yeah.
Which ones do we
Fair
have?
enough.
I gave you that green sheet a while back, remember? It was mostly green. It had all the identities on them. I think it was most of the ones that were on the upper half of the thing, plus a couple other ones. Yeah. Well, if you're not sure, if you forgot something, you just come up and ask me. And most of the time, when people come up and say, I'm not sure what this is, let's say, write down what you think it is. They actually are right. They're just not really sure. Yeah. Oh, man. This sucks so bad.
What happened?
I feel good, actually. This weekend, I felt horrible. So today, I sound like I felt over the weekend.
You go to a concert or something?
No, I just got a cold. Nothing exciting.
No.
You want to see the hobby? Oh,
Yeah.
I want to see the hobby.
I like that. Get Elvis back in gray. I don't know. I could try it. It's up to you guys. Let's see. Let's keep going on this. Maybe I can just let you guys try a problem out. I like problem number 4, which should tell you something. Right? So what do I mean by problem number 4? What does that mean?
Foil.
Yeah, so I want you to set it up and do it all by hand. And then I want you to do it using the Moivre's theorem. Right?
What was that?
Remember that was where you rewrite it in terms of r cosine theta plus I sine theta. Total. So I don't know if you guys want to try that one right now. And let me try my honey out. I've never. Sure.
Divided?
There it is. Me. I know, I found it on the floor. Take it outside. No, it's fine.
I believe in this thing already.
Yeah, I read it all the
I'm
time.
like, Wally, you said you were
My mom said that organic honey instead of any
I technically just packaged it.
Well, if it doesn't work, at least it tastes good. Sugar delivery device. No. I emailed it out. I had a few copies, but I ran out.
I need something that's secure.
Now this should be easy enough, I'm hoping. It just take you a couple minutes and you got it. Maybe not that long. The hard part to me would be remembering how to do this piece. And that's when you take something like this, you can put it in this form here. Now the Moivre theorem actually takes that form and raises it to a power. So that says if I have this, I get this, remember this here. And actually this idea of trig functions coming in and help me, that's actually working. This idea of trig functions coming in and help me do multiplications or whatever, repeated multiplication, that kind of thing comes in handy in a lot of areas of mathematics. So it's not just this one little theorem, there's other places where that idea comes in. So how do I rewrite this in that form? What can I find first? Yeah, what's R going to be?
So.
Stop.
17. 1 squared.
Yeah, 1 squared plus negative 2 squared. So R is root 5. And how do I get theta?
Inverse tangent of y over x.
Yeah, so tangent theta is
Negative 2 over 1.
complex over real, right?
Yeah.
So negative 2 over 1. Say it.
Yeah.
So this piece here is,
Where did you get the R over 5? Oh, okay.
good old x squared plus y squared. So R ends up being that thing a lot, right? This here you have to use a calculator for because that's not a value that we know. So if you do the inverse tangent, you just have to make sure you're in the right quadrant. What quadrant should I be in, by the way? Yeah, 1 minus 2, so I should be in the 4th quadrant. So thankfully, inverse tangent will give me exactly that. Because the output for inverse tangent will be in the 4th or 1st quadrant. So I'm actually in a quadrant that it works for.
I'm confused because we did it to the next one of 3 over there, but over here we got square roots.
Well,
why isn't it?
No, careful. Before I can do this, I have to have it in this form.
Okay.
And then I can do the power.
Okay.
So the first thing I have to do is just write this by itself in this form. Then I can apply the power and do this. Yeah?
So the tangent always be v over a?
It's always y over x. And in this case, the y-axis is now the complex axis. The x is the real, so it's complex over real. Unfortunately, complex rhymes with x, but be careful. So what do you guys get when you do this? Anybody help me out? Maybe in radians, yeah. Yeah, I know. Anybody want to help me?
Negative 1.11.
They do it again?
Negative 1.11.
1.11. Yeah, it's roughly what I got. Let's go negative 1.107. Cool. That's definitely in the 4th quadrant. All right, it's down 1.107. Pi over 2 is what? What's pi over 2 in in decimal form?
1.57.
1.57, right, roughly. It's 3.14 divided by 2. So this is not quite that. So it's in the 4th quadrant. I haven't got. So I know this is in the 4th quadrant. That's where I want to be. So I can leave that alone. So how do I write this now in this form? R root 5 cosine of theta times n plus I sine of theta. Here it is. So how do I do 1 minus 2i to the 3rd power?
Root of 5.
Yeah. Root of 5 cubed. Cosine of 3 times that.
3.321.
Thank you.
If you were to minus it from 2 pi, then would you make r negative? Like if
Oh,
if
yeah,
made
if you
it
mess with the
positive,
angle, you might have to mess with the R to make sure it ends up in the fourth quadrant, sure.
Do you want to keep it negative? As long
Yeah, I
as-
want to keep the angle. It's normally the angle that we adjust. It's kind of convention, and actually for some things, you don't want to make the R negative. You want that information to be in the angle. Does it make sense? Yeah. So if I were to do square root of 5 cubed times cosine of this, what should I get?
Oh no.
Whatever you got when you did this. Did anybody actually do this?
Oh no.
Oh no.
I was watching this stuff.
1 minus 6i plus 10i squared minus 4i.
All right, and then you can make the I squares become -1 and so forth. Yeah. So we do this. This will be 1 minus 2i minus 4i plus 4i squared, right?
Minus
What's I squared?
negative 1.
So 1 minus 4. I can do it, Jeff. 1 minus 4. There you go. And then just do it again. So you get -3 minus 4 plus 6 is plus 2. Plus 8i is minus 8. So you should have -11 plus 2i, I think. Yes, cool. Now, somebody try this out for me. Do square root of 5 cubed times the cosine of this. Make sure you're in radians. It's not going to be perfect because this is an approximation.
You have calculator?
Negative 4.9.
I,
But how is the sine, imaginary sine?
who knows?
Honestly, do you need it?
That's all you need, right?
Do you need it or?
No, well, not for right now. What'd you get? Anybody do it?
But does the imaginary sine matters?
No, just do this piece.
Huh?
Just do this.
Oh.
Is anybody doing that?
I got negative 11.0008.
Right? Didn't come out to exactly -11 because again, that 3.321 was an approximation. That was a decimal that went forever. I didn't feel like doing that. I could carry around the inverse tangent of -2 and just have that in there. That would be exact. But you know, this approximation, just to check myself, they came out pretty damn close to -11.
Yeah.
So incredibly enough, if you do this times sine of that, you'll get pretty much close to 2. Don't worry about the I, that's just the piece that's attached to it.
I didn't know there was supposed to be
I
sine.
cubed is
Oh, so I squared is -1. So I cubed is I squared times I, so -I.
I got 1.995.
There you go, which is trying to be 2. It's not exactly 2 because this was an approximation. I'm going to cut off the decimal somewhere. I don't know if you guys are with me at all or not. But
I'm gonna try.
at the end of the day, if a theorem is trying to tell you a shortcut for doing this kind of thing, then if you do this kind of thing the long way, it better come out the same damn answer. That's all I'm doing here is making sure that that freaky looking thing is exactly what you would get if you did it the old way. It's got to be true, or else we could throw the theorem out. Unfortunately for you, we can't do that. It's true. Okay. So where do you want to go next here? Let's see.
Oh my god, that is freaky.
This should not be
You
freaky.
do get it.
It should be cool, but on one level you should go, well, of course, duh, that's what it's got to be. That's what it's got to be. Oh boy, what about synthetic division? Normally, once you've done it a couple times, you remember it pretty well. Especially because your brain goes, wow, that's useful. So you remember it better. Some math, you don't see the usefulness of it right away, so you forget it very easily. Synthetic division normally sticks with us pretty well because we're like, okay, that made that problem a lot easier. Let me remember that. How do I even start that problem though?
Write it out.
What's the first step?
Take out the x's and just write it out.
Constants and all in order.
What am I going to put in the little penalty box? What am I going to divide by?
Negative first number.
What could be
A
the
ratio
answer?
of the first constant and the last
It could
number.
be
All the
1,
nines,
3.
write down the nine.
Oh, let's
Or
look.
9.
Oh, the
Good.
factors of the.
So any factors of 9 divided by factors of 1, which doesn't change anything.
So it will be 9, 3, 1.
9, 3, and 1, plus or minus.
And then what about?
So if you tried it,
The lower bound.
The upper bound and lower bound is bound.
oh yeah, that could come in. So we try like 3 maybe. What is it? 1, 5.
3.
3.
3 is that.
So how does this work?
Drop the 1.
Drop the 1.
Multiply
1 times
3, 8,
8.
24.
You can pretty much see that's going at it.
21.
That's going crazy, right?
27.
27, yeah. So that's not going to work, right?
How do you know?
Why do I know it's not going to
I
work?
don't know.
Pull it forward to 9 and 3s.
Careful. All right, 1, 3, 8, 24. 27 times 3,
This is like a big number. 81.
81. That's not 0.
Oh, yeah, okay.
So obviously I don't want to use 3.
Try negative.
Negative 3.
Yeah.
So 1.
Bam. Good.
Sweet. Cool. So then what does this mean?
X
means that
squared
x
plus
cubed
2x minus 3
squared
times.
plus 2x.
Is x plus 3 times
The rest of that.
the rest of this, which is,
X squared plus 2x minus 3.
Wait, x plus 3?
where'd that come from?
What?
From negative 3.
Because he factored out 3.
Because that's what the root of that would be, right?
0 and negative.
So if negative 3 goes into this synthetically, that means that x plus 3 goes into this long divisionally. Right? Why is this negative? Because remember, we changed the sign first instead of every damn time. Long division takes so damn long. Now how do I finish this out?
Simplify.
Just
Factor.
Yeah, this is easy enough.
this.
You're recording, right?
Yes.
Yes.
Why do you choose
I
negative?
don't think I can see all the way over here.
No.
What's that? Why? Had you choose something, right?
Yeah, why did you choose negative 3?
Why not? Why don't I choose 4? That's a better question.
It wouldn't work.
It's not a factor.
This is not a factor of 9.
9.
So I try all the factors of 9 until I've tried them all. And I go, damn, that guy's evil. None of them work. Obviously, I'm going to make something work. So if negative 3 worked, what else would have worked?
Probably
1.
1. 1 would have worked because x minus 1 is there. It's a factor. Okay. Then this will help you with the next problem. The next problem says, all right, take what you did in number 5 and find all this. Remember that beautiful stuff and behavior.
Oh no.
Yeah.
Why? Is this by the way, is this math, a department final or is that your final?
It's my final.
Okay.
I don't know how that makes you feel.
Better?
Better, okay.
I don't know what the other teachers are thinking.
That's the truth. All right.
Simplify this.
So whenever you come up with a synthetic division, you know, it's the negative number comes up with x is the first factor.
Yep.
Graph y equals mx. Find the y-intercept of this.
All right, guys. So what would the intercepts be for this?
3 and
So even better. Negative 3, 0, and 1, 0. What's the y-intercept? Negative 9. Right. It's easier in that form. Let x be 0, you get negative 9.
Oh yeah.
What are the multiplicities here? Negative 0, negative 3 squared is 9, times negative 1 is negative 1. What are the multiplicities of these? What's the multiplicity of negative 3? What does multiplicity mean?
2.
We don't know. I have no idea.
That's when it goes through or
How many times does negative 3 show up as an answer? Twice.
Twice.
That's what multiplicity means in this case, right? Not that movie by Michael Keaton, which really. What about this guy then? He's got multiplicity 1. What does that mean in terms of visually? What's going to do at negative 3?
It's gonna go through.
Yeah.
No, it's gonna touch and come back.
Yeah, 50-50 chance. So this one's going to touch, right? This is going to turn, however you want to say that. And this one's going to go through. It's going to turn there because it's going to do what a parabola would do at its root. It's going to turn. And this, a line, its first power, we go through. That's all.
So it's gonna be squarish, maybe?
Yeah, what's the end behavior?
Cubish.
Yeah, the end behavior is cubish, right?
How do you know that?
Because it's a 3 in the beginning, remember?
I'm losing people. Here, let me give you this answer key before more of you guys leave.
Yeah. Disagree with you.
I don't know. This is one thing I definitely would make sure I have.
If we hadn't done step 5 before doing step 6, I don't factor it down the same way to the x plus 3 squared.
Maybe.
Okay, you don't be so picky with your graph. Just this final.
What's that?
Your graph so picky in the places.
What's the highest score you ever got in a pre-calc final, Waller?
Waller, in the history of the spinal, highest score. What is it?
Actually, I taught pre-calculus. Probably the last time I taught it was 4 years ago or something.
What was it?
It's been a
Is
while.
there gonna be a bonus section?
Yeah.
So, could somebody score 110?
No, you could
No?
score 106.
What? Come on.
Are you gonna grab the final?
I like that. You're gonna. I can't wait for your letter to my department chair. If he would have just let me score 110. I would have.
For like the credit, you're gonna be on the section you're gonna do it?
Yeah, some of the bonus will probably be from the sections that I made extra credit, and some of them will be for everybody. Yeah. All right. Where
I
are
have
we
a
at?
question.
Oh yeah.
Are you grouping final?
I'll have to wait and see. All right.
Maybe.
So when I go to graph this, what do I graph for? Oh, sorry, Fred.
So the x-intercept is the first one, and then the y-intercept is the second one.
Yeah, X and Y.
How did you get the y-intercept?
How do I find the y-intercept of anything?
Make it 0.
Make X 0.
How did you get?
The multiplicity, if it's even and it turns,
Yep, even multiplicity turns, just like parabola would, because any even power would be parabolic. Odd multiplicities go through, just like any cubic type thing, or actually the fifth power would look like the same thing. It goes through its roots.
How do you think it's gonna look like that?
All I know is at the ends it's got to go down here and up there. And why do I know that? Because what's the highest power? Q. So it's got to be cubish.
So it pretty much is gonna go like at negative 3, it's gonna touch it and go down and up. Like down to negative.
Yeah, it's got to turn at 2. It's going to go up, turn, and it's going to go back up. Yeah.
does the exponent also like determine whether or not it's cubish or parabolic?
Not on each individual thing, no.
Like the first one, like if it's
The end behavior is determined by the highest power in the whole thing, not in each piece.
I have a question. Are you gonna be fine if you only do those 3 points? Like touching at negative 3, then going down to 9 intercept, and then going through 1?
Let's graph it, see what happens. Yeah.
No, because usually you judge my graph very harshly.
Not just yours.
so if it's even, it's cubish, like the highest power.
What's the highest power? And this is not 2.
It's
3. That's why it's cubish. Okay. So we're going to graph this. I can start with my intercepts. Those are my anchors. Right, so I've got -3, 0. Got 1, 0. And I've got -9. Okay.
See your graph book? You should be mad.
What are you talking about? If you had a graph like this, and you do it like I'm going to do it, you'll be fine. Now I could find a couple other things. I could graph it very roughly right now. I could actually say it goes up, it touches at -3 touches, goes back down here, goes back up.
I do that and then you say I'm
To be, like I just said, I could do that. Now if I ask for more points, I could find maybe -1. When you plug a -1 in, what do you get out?
Oh, yeah.
I get 4 times -2, I get -8. So -1 is -8. That's looking pretty good right there.
So because I remember like, yeah, that's right. On the exam, on that one test, you ask us.
You have to find additional points.
You ask us to find 3 additional points. And I didn't remember how to do it. I was like, I don't know.
All you gotta do is plug in a value for x.
Yeah. And then
Okay. Yeah.
If we had it done number 5 first, and so we just take the x to the third plus 5x squared and factor it to be able to do this, I don't get equaling the same thing. I don't have the same, it doesn't factor down the same. I don't know what I'm
It
doing.
has to.
Because of the
I'm not sure how you're
size.
trying to factor it. You can't group it.
Oh, you can't.
Won't work. Grouping does not always work. Just because grouping doesn't work doesn't mean it's not factorable. It just means that it won't work on that problem. It's got to be a very specific type of problem for grouping to actually work. Yeah.
So if in number 5, if there was a screenshot of the x cubed, the only things that would work would be one divided rate?
No. It's all possible ratios of all factors of the last one to the first one. So it'll be 9/1, 3/1, 1/1, or 9/3, 3/3, 1/3. So it actually add in the possibility of plus or minus 1/3. Yeah. Okay. Maybe.
Can we do 7?
Maybe, oh, you had to say it one last time.
7?
Yeah.
Yeah.
That's it.
All right.
That's it.
Now let's do number 7. I think it's the one that more relates to being careful about at the end about finding other points in the middle. Because at that point, you can't just say, oh, here's an intercept, and then I just go, yay. No, I want to know how low does it go. Find the thing right in the middle and see it. Get an idea of how low it goes. Because maybe it should have went like this. I don't know.
I don't know. Maybe it's like,
All right, so we got this here.
Well, the video has it, but technically I do have it.
no, the video turned off a while back.
What?
What do you mean?
Turn the video
It's
on?
still good.
It's fine.
I thought it did.
And you can't even see it.
Yeah.
It's fine,
He
yeah.
was about to cry.
It's not on. I don't know what.
Okay.
Oh my god. I'm gonna miss this one. Learn something.
All right, first thing I should do on this problem before I start trying to see intercepts and asymptotes and all that, what do I have to do?
Factor.
Factor. How do I factor the bottom here?
X plus 1, X plus 2.
X minus 4, x plus 1.
Bigger one negative, so you make the middle term negative. So from just doing that, what can we see is true about this graph or this function? Yeah.
Oh my god. I don't like that.
So it's like x minus I, which
So I know the x-intercepts are what?
Imaginary.
2
2.
and negative 2?
-2. What else can you see?
There's asymptotes at -1.
What kind of asymptotes?
Where
Vertical asymptotes.
-1 and -4.
Cool. Remember that? Vertical asymptotes are walls that say you cannot go here. So they must be related to the domain. They must be related to what x values I'm actually allowed to use. So vertical asymptotes comes from the denominator in this case, though. What's going to affect my domain?
Horizontal.
Yeah, where did the horizontal asymptote come from? You can see that from here.
Powers.
Because the ratio of the powers are the same.
The powers, the degree of the top and the bottom are the same. Therefore, since the degrees are the same, the horizontal asymptote must be
One.
the ratio of those coefficients 1 to 1, so it's just 1. Don't just put 1, but y equals 1. Asymptotes are lines or curves. You got to give me an equation for them.
I have a, something that kind of confused me about it. It was like, so vertical asymptotes, it's like walls that cannot pass, right? But the horizontal, they can pass it.
Hell yeah. Because horizontal just says what must happen when x gets really, really big, positive or negative. So like I said before, I can have a horizontal asymptote that I pass an infinite number of times. Because what am I doing? I am getting closer and closer and closer to the value, am I not?
Yeah.
But I pass through that wall billions of times. In fact, an infinite number of times. So some of you guys might realize this is sort of like a sound wave. You pluck a guitar chord, you wait, and the amplitude decreases. Of course, theoretically, it would keep going forever, but in reality, it stops at some point. So this would be infinite sine waves going bouncing around. Okay. So horizontal asymptote, you can definitely go through. But a vertical, you cannot, because that says you cannot exist here. Horizontal is more suggestion. It says, at some point, you better come close to me. Right? I know it sounds creepy. I think it ought to come at some point.
Like, why is it creepy?
My teacher told me.
It's just not.
Pass this class. All right.
Yeah.
All right, so what else do I need before I can graph? Y-intercept. How do we get the y-intercept? To make x 0. -4 over -4. Cool. Yes, ma'am.
I'm sorry, but can you help explain to me how you went from the factors to the x-intercepts? Just real quick.
What's the only way now to get the intercept, to get the x-intercept, you make y 0.
Y
So 0 equals this. What's the only way this fraction can equal 0 is if the top is 0. And once I factor it, I can see what makes it 0. What makes that be 0? 2. What makes that be 0? -2.
And then 0 divided by whatever.
It's only the top part, and then you just
Exactly.
factor in the bottom part for the vertical.
Vertical asymptotes comes from the domain, which comes from the denominator of a rational expression.
And then horizontal asymptote.
Horizontal asymptote is that 3 possibilities, right? The top power is higher, the bottom power is higher, or they're the same.
They're equal.
Or the bottom.
What happened when I forgot which one is, because when it's the ratio is when they're the same.
Yep, that's what we got this from.
And then when
What if
it's,
they're like this?
The bottom one's bigger,
uh-huh.
so the bottom gets bigger faster. If I'm dividing by bigger, 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 my answer keeps getting smaller, 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 my asymptote would be 0. Y equals 0. It's if the top one is bigger, that's the worst one. Because what kind of asymptote do you have then?
Horizontal.
The top one is bigger, it's going to infinity. But it's going to be a slant asymptote.
Oh, that's the one we did.
Oh yeah. That's why you have to do long division to figure out what a slant asymptote would be.
Are you putting one of those?
No.
Should we
I
study
haven't
it?
decided yet.
No,
There's
no,
no
no.
need. If we know the other 2 ways.
Are you gonna put a lot of like work on?
I'll put a few, yeah. She's not giving me ideas.
You already have it done pretty much.
Proof quick.
You
can take the group.
Yeah.
Leave it in your hands.
Yes.
For the y intercept,
But I'd
is
like
that
to draft
3
take home
lemons
card.
for X?
So I don't care what class you're in, guys. In my last math course I took, it was like math 896 or some stupid thing. To find the W-intercept, I made all the other letters zero. So in general, if you want to find the intercept of anything, you make all the other variables zero. So for right now, how many variables do we normally have? Two. It could be three. But for the most part, two variables. So how do I find the y-intercept? Make x zero. How do I find the x-intercept? Make y zero. That idea holds. I don't care how many variables I start throwing into something. Then I'm going into third, fourth, fifth dimensional space. Holy shit. But to find intercepts, I just make all the other letters zero. Cool. Don't forget that ever. Don't make more out of it than what it is. That's all it is. So what can I graph here?
Oh, yeah.
Oh.
First
Oh.
one. Oh, the asymptotes.
All right, so I can do the asymptotes. So the vertical ones are at -1,
Our wall.
and 4.
So it's gotta be somewhere in the middle.
Yeah, so it could be something funny in the middle. Horizontal asymptote y equals 1. I'm about to be conservative here, I can't remember. So y equals 1.
Your skills. It's me. That's what you always put on mine.
Yeah. Man, my grade's going down now. Oh, yeah. I automatically pass my class. X-intercepts,
I'll
right?
rate my professor. Yeah, we'll rate my professor.
2-0.
Like my professor's like, I'm supposed to.
That's so much shit, by the way.
All they're gonna.
When I first heard about it on the East Coast, and there was something, one of my colleagues wrote to all the other professors, have you guys heard of this new website? The next day, you could go in and take a look, and all the instructors had reviewed themselves. And one guy put down, he is the essence of the essence. I'm like, dude, that is
when I read
you.
when you read those like those things where it says like too worthy, too nice, it's like man, that was a professor.
And
Yeah, I
then
know.
they have a pocket scale
Do
too.
professors get mad about it?
It's funny when
Yeah,
you
you ever
see
met someone that got
Sure,
really mad
somebody
about
I
it?
does.
see a bunch of bad reviews and one that got very clear, thorough instructions.
The last time I looked at it, somebody wrote down that I give too much homework. I'm like, whatever. What else have I left off here?
Y-intercept.
Yeah, the y-intercept. Y is 1.
Actually, I believe it's like a BS for
I wonder what's the water room.
wrote you like a 4 on the easy scale.
Handsome.
You're
Real quick.
easy.
You guys see right here, this is like your question. I have a y-intercept that's on my horizontal asymptote, right? So when x is really small, my outputs can do whatever they want to. It's only when x gets really big that they have to start to approach this. So this is right on top.
When you
Y-intercept is 1.
when you make X 0, right?
Yes, cool. So in the middle, I basically know what it's going to look like. Could it start here?
No.
Because there's nowhere through. It's got to start up here and come through there and down.
What would it be curious?
But to be more specific, I think on this one I said, did I? Oh yeah, it said find f of 3 and f of 5. What's f of 3 and f of 5?
Oh my god.
Okay, 3, that's 9 minus
5
4.
over -4, right? -5/4. I think.
Yeah.
And then f of 5.
21.
Lord.
21 over
5 squared is 25. 21 over 6.
Yeah, 21 over 6. Okay.
Oh,
so
divided by
f of
3, divided by 3. Hey, you have to reduce
You
it.
can reduce.
Reduce it.
Yeah, Jeff's gotta reduce.
All it means is 3.5. That's weird.
7 over 2.
So
Oh, yeah.
f of 3 is -5/4, -1 1/4. Want to be more precise? It's gotta be right there. You guys kind of with me?
Yeah.
Everybody cool with how I figured out it looks like that?
How?
It can't possibly start here because there's no other way through. It's got to start up here and come back down. Yeah.
The horizontal asymptote doesn't stop it, right? It just keeps going.
The horizontal is only comes into play when it gets really big.
That's really weird.
Yeah.
And then don't you do the other ones too?
Yeah, now I've got to do the other sections. So here, the only two possibilities according to the asymptotes are it could be up here or down there, and obviously it's
Down there.
down there. There's an intercept there, so it's kind of like that. To be more precise, I can figure out what for whatever is here, but there's pretty much only one way it could really be.
How do you know that it's How do you know that it's
I don't. I know it's got to slam up against this. I know it's got to go through this. I know it's got to go through that. And then I know it's got to slam up against that.
Why wouldn't
Why can't it go back up?
Oh,
if it's x squared, wouldn't it be a problem?
because what's the multiplicity of this root? On the all one,
Oh, yeah.
it's got to go through. That's also why when I did F3, we saw it's down there. But you're right. In general, it might turn back, but I know it doesn't because it's a multiplicity of one. Yeah.
Why couldn't it start down and go up?
Because there's no door here. This was my only intercepts. There and there. Are there more x-intercepts? No. Because with,
Yes.
I can't possibly start here because where does he go through?
You can go like, yeah, you can go like all the way over here, and then.
Then it wouldn't be a affliction. I wouldn't pass vertical lines.
Oh.
See? Now where's it got to be over here?
Nowhere.
It's up there at the top.
So it definitely can't be down here then. So try again. It can't be down here.
So it's gotta be up.
So it's got to be under here.
Also, there has to be something.
Yeah.
Oh.
Because I can let and just be really safe.
Until it speaks.
F of 5 is 3.5, right? So F of 5 is 3.5.
I'm gonna see it.
So you can just plug in points yourself?
Where did you find that?
F of 5. When x equals 5.
Oh.
Just for sure. But you already knew it because there's no intercept. So you know it can't be down here. So it must be up there. Is that simple?
Yeah.
Yeah,
I want to know if I have anything else. I want to know if I have anything in that step.
you do. Yeah.
What section was this?
What's that?
What section was that? You remember?
What we're doing right now?
Yeah.
I truthfully don't remember.
What's it called?
Probably like 4.
It's fine. It's early here.
Probably chapter 2. I would have thought. No, it's chapter 3. Yeah, chapter 3. Yeah. So we're going to do the final in place. I was hoping to talk to you in another classroom, but you never showed up.
When?
In class. What's your final year? All right. So where else do you guys want to go?
Come Wednesday for office hours.
Okay. What's up?
A word problem?
Word problem.
Yeah, word problem.
I do law.
Hey, Waller.
Yeah.
See the new treasure for circus?
Yeah.
You saw the trailer?
It looks freaky.
Do you know who the villain is?
Did you? Yes.
They haven't said the name, but they going in. Is it
Don't
con?
distract.
Is it con? I'm trying to figure it out.